So now that we have introduced logarithms and talked about their basic evaluation and their basic graphs, we're going to take a look at manipulating logarithms in an algebraic sense, that is, in equations and expressions. So there's a few properties for logarithms that we're going to learn. I know there's a lot of points on my list here. Each one of these is relatively short. There's more than I normally put. But the first thing we're going to talk about is change of base. I covered that more fully in 7.4, if you want to watch that again. But in 7.5, you're going to find the practice exercises for it. So we'll review that first. Then we'll talk about the product rule, quotient rule, and power rule, which are the three ways that we manipulate logarithms. Then we'll do some examples. The two biggest examples using the three rules are expanding logarithms and condensing logarithms. So those are 5 and 6 are mostly examples of how we use the product rule, the quotient rule, and the power rule. So the change of base formula we learned already, although your book doesn't teach it until 7.5. But the way the change of base formula works is whatever base you have when you start with, it doesn't really matter, B, A, you can change the base to be whatever you want, but when you do, you create a fraction. So you do whatever base you like with the original argument, and then on the bottom, you do the same new base, but with the old base for its argument. When you do this, it's important, this makes a fraction. The fraction has two logarithms on it, which is not what happens with any of the three rules we're learning today, product rule, quotient rule, and power rule. This is very distinct from the other three rules, which is one of the reasons I talked about it more in 7.4. This is really only useful for if you're putting a logarithm into a calculator that doesn't have a log base function. The old TI-84s or a scientific calculator may just have log and ln. Speaking of which, you can certainly do this with ln. ln is just base C and base E, and you can pick whatever base you like. So my one example I'll do for this, log base 2 of 7, which are numbers I just kind of picked out of the air. And how you would put this into like a scientific calculator is you do log of 7 divided by log 2 and get a decimal approximation. That's the change of base formula. The product rule, as far as why the product rule is the way it is, it has to do with exponent rules. If you remember, the answer to a logarithm is always an exponent. That can really help you out. I won't bother to prove it. I will just mention the rule. Now, the product rule says that the logarithm of a product, r times s, for example, is equal to the sum of the individual logarithms. And that has to do with the way that we add exponents together when we multiply powers with the same base. I said I wasn't going to do that. I'm sorry. So in this case, like an example would be log base 2 of 16, which we know the answer to, because 16 is the power of 2. But we can also split into two smaller logarithms if we find two numbers that multiply to 16, like 2 and 8. So log base 2 of 16 is equal to the sum of log base 2 of 2 and log base 2 of 8, because 2 times 8 is 16. That's what the rule says. Just to show you what I mean here, 2 to the 4th power is 16, so this one is 4. 2 to the 1st power is 2, so this one is 1. And 2 to the 3rd power is 8, so 1 and 3 makes 4. This will work however you split it up. If you do 4 and 4, you'll get 2 plus 2. If you do 16 and 1, you'll get 0 and 4. So this will work no matter how you split this up. This can be useful for breaking down a logarithm or for combining logarithms together. You can only combine them if they have the same base. We'll get to that with the examples. But this is the product rule. The quotient rule is very similar, but the quotient means the answer to a division problem. So the quotient rule has division on the inside. It says the logarithm of a quotient is equal to the difference of the individual logarithms. So an example for this, ln of let me not use ln. Let me use log base 3 of 27 over 9. Now we'll know what the answer is going to be. The answer is going to be 1 because 27 divided by 9 is 3, and log base 3 of 3 is 1. But this should be the same as log base 3 of 27 minus log base 3 of 9. 3 to the third power is 27. 3 to the second power is 9. 3 minus 2 is 1. That's the quotient rule. The third rule is the power rule. Now the power rule says if there is a power inside a logarithm, then you can actually move the exponent out front as a coefficient instead of as a power on the inside. A power on the inside is the same as a coefficient on the outside. Log of r to the s is equal to s times the logarithm of r. For example, log base 4 of 4 squared is equal to 2 times the log base 4 of 4. Log base 4 of 4 is 1, 2 times 1 is 2, and 4 squared is 16. Log base 4 of 16 would be also 2. You can also think of this as if you have something like 3 to the 4th power, you can split that up into the log of 3 times 3 times 3 times 3. And the product rule says that's log 3 plus log 3 plus log 3 plus log 3, which is the same logarithm added 4 times. 4 log 3. So this 4 can come right out front and be the coefficient on the front. It might be a little silly, but I always think of this as flicking that little exponent. You're like, flick, and it goes, and falls out front. It helps me remember what I'm doing. You can flick it up to the top 2 from the other side. But be careful because it's easy to miss. It's harder to get stuff in there up high. That was a joke. Okay. Quotient rule, power rule, and product rule. So those are our rules. The last 2 things I have to do is show you what you're expected to be able to do with them. And for now, the only 2 things you're expected to actually do are expanding logarithms and condensing logarithms. So you can expand a logarithm that has only numbers in it. For example, ln of 24 over 14. No, that's a bad example. 15. Okay. Well, those are both multiples of 3. Well, life goes on. So when you have a fraction on the inside of a logarithm like this, you can use the quotient rule to split it into a subtraction problem. So we split this up, ln of the top part of the fraction minus the ln of the bottom part of the fraction. Pretty straightforward, that's the quotient rule. When you're expanding, you want to expand as far as you can. So the idea here is to get these and break them down into their basic components. So 24 is 8 times 3. So we can split the 24 up into 8 times 3. We can split the ln of 15 up into the ln of 5 and the ln of 3. Now here, just like we could have reduced before, you'll notice the ln of 3 here minus the ln of 3 over here, if we distribute that negative sign, is going to cancel, which is why I was saying this is probably not my best example. And we end up with the ln of 8 minus the ln of 5. This was a lot more useful back before calculators could do logarithms, because there used to be a table in the back of the book where they had a whole bunch of ln's listed, and they didn't have fractions. They kept only the whole numbers in the table. And so you would go to the back and you'd find the ln of 8, and you'd find the ln of 5, and you'd subtract them, and that would give you the answer to a fraction like this. We have calculators. So expanding with just numbers, not particularly useful anymore, although you'll find a couple in your homework set, because it is a good way to get used to these rules. More usually, we'll use expanding logarithms if you have more than one variable and you're trying to separate them. Expanding logarithm, this is called expanding, in case I wasn't clear about that. Expanding logarithms, you take one complicated logarithm and you divide it into several much simpler logarithms. That's the price you pay. You make the insides simpler, but the outsides get more involved. And then condensing, when we do it, you'll have the exact issue. You'll take something that's simple on the inside but complicated outside, and you move all the complexity inside the logarithm. So here's an example. It's got variables inside, which doesn't change the process at all, but it actually is a reason why you might have to do this, because you sometimes want to separate your variables. So here I'm going to use the quotient rule first to split this fraction into its two parts. So log base 6 of the top, 5x cubed, minus the bottom, log base 6 of y. Now this one's already as simple as we can get it on the inside, but this here is a product. So this is log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. And here, since I have an exponent, I can pull that out front. Log base 6 of 5 plus 3 times log base 6 of x minus log base 6 of y. Now each inside is just one thing. It's as simple as it can get. We've produced complexity outside the logarithms, though. So this is called expanding. The opposite of expanding is condensing, and we'll do a couple of those as well. Condense the logarithm. ln 8 plus 2 times the ln of 5 minus the ln of 10, for example. We notice the coefficients are what I'm going to do first. I'm going to do it in the reverse order. The last thing I did here was the coefficient. The power became a coefficient. It's the first thing I'm going to do with condensing. So that becomes ln of 5 squared, which is 25. So when I write that on the next line, I will write 25. Then I'm going to add these two logarithms are added together, which means multiply the insides. That's the product rule. So this is the ln of 8 times 25, remember 5 squared, minus the ln of 10. And this is going to make a fraction. This is division, because subtracting two logarithms, you divide the insides. So ln of 8 times 25 is 200 divided by 10. Now, unlike the change of base formula, when you're condensing a logarithm using the power, product, and quotient rules, you only wind up with one logarithm. This does not make a fraction with two logarithms in it. The logarithm of a fraction, not a fraction of logarithms. In this case, 200 divided by 10 is 20. So the final answer is ln 20. Let's do one with variables in it. 5 times log base 4 of 2 plus 7 times log base 4 x plus 4 log base 4 y. So here I'm going to take this coefficient, 5, and turn it into a power. Log base 4 of 2 to the 5th power, which is 32. 7 times log base 2 of x becomes, log base 4 of x becomes x to the 7th, and this becomes y to the 4th power. Since these are addition, this is going to turn all into multiplication, so it'll be 32 times x to the 7th times y to the 4th. And now we've taken three separate logarithms and combined them into one logarithm. That's condensing. Expanding is the opposite. Okay, so that should be enough to get you started. If you have questions, let me know.